In this video, we're going to look at how to use test-driven development to build a web front end that queries a REST API. I'm Bill Sarur from Dev Mastery, and you're watching Mastery Monday, the weekly show that helps you write better code and advance your career. Please subscribe and hit the notification bell so you never miss an episode. Before we begin, I just wanted to give you a quick heads up about what to expect in this video. This is not a step-by-step beginner tutorial on web development or even TDD. This video is a more advanced look at front-end development where I show you a specific approach to using tests to drive your UI development. And we'll also explore some of the tools that are used in this approach. So if you've just started learning to code, this might not be the best video for you. But if you've already had some experience building apps, I think you'll really enjoy it. Okay, let's jump in. Okay, so we're gonna build this little app right here. We enter in a title of a movie, like Batman, press the search button, and we get a bunch of posters for Batman movies. Now what's going on with this app is behind the scenes we're calling an API from the the Open Movie Database. So this is a free API that you can use. There's a couple of gotchas. So if you get a free API key, you're only allowed 1,000 requests per day, which might be troublesome if we were building a real app. So that would be something that we'd have to take care of, especially if we're doing test-driven development and calling the API over and over and over again. That may not be so practical. The other thing about this is obviously we don't own or control this API. This is a third-party API that we're just consuming. So the responsibility for testing the API is not ours, but also there are no guarantees about the state of the API, nor can we control the responses from the API. So we're going to have to deal with that. The other thing is this is going to be a modern web app. So things like typing in our movie title, and when we hit enter or press the search button, we're going to want to see some kind of spinner or indication that it's searching. Basically, the UI is going to have to update different parts of the screen at different times without refreshing the entire page, because that's how modern web apps work. And you'll see that's quite tricky to do from a test-driven development point of view, but I'll show you how to do it. All right. So what we're going to use to build this app is we're going to use something called Puppeteer. So this is a product by Google, and what it allows us to do is it allows us to drive a browser using code. So we can basically code instructions to a Chrome browser and have the browser perform different actions like typing in a text box or pressing a button. We're also going to use Jest. So Jest is a tool for testing. So whereas Puppeteer is just a tool to control a browser, Jest actually allows you to perform tests. So when you combine Jest and Puppeteer, you get a really interesting framework that allows you to test your app as if it was being used by a user. In other words, you're going to test your app from the user perspective. But I'm getting ahead of myself. The first thing we need to do is start to understand a little bit about how this API works. So anytime you're dealing with an API that you don't control, the first thing you want to do is get to know the API. So what I have here is a tool called Postman, and that allows me to query an API. It allows me to send requests to an API with different parameters and see the response, the JSON response that comes from the API. And so this is a cool way to sort of interact with an API and get to know how it works. So here I've sent the same query that I showed you earlier, Batman, and you can see what the results look like in the JSON format that they're returned in. I can also come in here and test out how the API behaves under different circumstances. So let's say I just put in a bunch of gibberish. So I wouldn't expect this to find anything. So we'll hit the send, and we see this is what an error response looks like for no movies found. We can also come here and just enter a single character, and you see we get a different error, too many results. So this tool allows us to play with the API and get to know how it works. Of course, you can use many different tools to do this, but this is the one I like. It's free. It's called Postman. They don't pay me anything to say that. It's one that I use all the time. And so with this now, we can get a sense of how the API works, and we're going to be able to create test fixtures. So test fixtures are like static dummy data that we can use to return in place of real values in order to save first of all, the time required to do round trips to the API. And second, we've only got 1,000 requests per day, so we don't want to burn through those too quickly. So we're using the real responses to generate fixtures, which are going to be dummy data that we're going to use in place of actually calling the API. So let's jump into the code and I can show you what I'm talking about. So I've set up some boilerplate code for us, which I'll link to in the description. This is an app that I created using Create React App, and then I added Puppeteer and some configuration to make Puppeteer work with Jest and Create React App. I'll put in the description links to information on how you can do that, and also to this code so that you can download it. The other thing I've done is I've created a folder called Test, and in here I've added our fixtures. So this is what I was talking about before. So under the fixtures folder, I have this API, and I've got a few different fixtures, which we'll look at later, that simulate or look like the responses from our API. I also have a search spec here, which we'll go over in a minute. In the source folder, I have another folder called poster search, and that's going to have our component, so our main component that does the searching. And this is just a mock-up right now, so there is no active code in here. There's nothing interactive about it. It's just basically the HTML markup. Okay, let's start coding. So on the left-hand side, we have our test suite, and on the right-hand side, we have our component. Now, as I mentioned, this happens to be a React app. But what I'm going to show you actually will work with any framework you want to use. So this will work with Vue, with Angular, or even with server-side frameworks like .NET, PHP. It doesn't matter. The reason is because we're using Puppeteer to drive our tests from the perspective of the browser. Anything that runs in a browser can effectively be tested using this method. So yes, this is a React app, but don't worry if you're not a React developer. That's not necessary. You can do this technique with any framework that you choose to use. You'll notice this setup is really cool. You've got a test on the left, code on the right, and a terminal on the bottom. And this is the way that I like to set myself up all the time when I'm coding. I find this makes me the most productive. So at the bottom in the terminal, we're going to do two things. First, we're going to start our app, so that we're running a development version of our app that will automatically refresh as we change files. And then we're going to start our test suite and have it continuously running so that it can watch our files, and as we change files, the tests will rerun. You'll notice at the bottom we have a bunch of skipped tests. That's because my test descriptions are written with an X in front. So the X causes them to be skipped. I like to do this to give myself a kind of to-do list that will tell me what I intend to implement in terms of the behavior of this particular feature of my app. In the future with Jest, we'll actually get a .todo keyword, which will give us a prettier interface. It'll actually say, instead of skipped, it'll say to do at the bottom in a nice purple color. So if you're using a modern version of Jest, instead of putting an X in front, you can just do it.todo, and that will give you your little to-do list. And so you'll notice I'm describing everything from the perspective of the user, with myself being the user. So I have things like it tells me when we're searching. It tells me when there are no results. It tells me how many results were found and how many are being displayed. And I like to use kind of natural language and just give myself this kind of to-do list to tell me what it is that I'm going to implement. So let's start by implementing the first one, which is it doesn't let me search until I've typed at least 3 characters. And that comes from playing with the API. I noticed that anytime you tried to search for something with only 1 or 2 characters, you usually got an error that said too many results. So there's no point in letting the user type 1 or 2 characters, hit the search button, and just get frustrated because they're getting an error. Okay, so with Puppeteer, there's a little bit of ceremony before we begin. You'll notice that I've got this before all block up here. And what this is saying is when the browser disconnects, close the browser. And that's because in watch mode, at the end of each watch cycle, the browser is going to disconnect, and I want to actually close the browser so that I have a fresh new browser each time. And then before each test, I reset the current page and I navigate to my local host, my local running dev instance of the app. And the reason that I do that is because before each test, I want a brand new page. So it's as if the user just landed on the page and we're starting with a known sort of virgin state. Okay, so let me show you what a Puppeteer test for it doesn't let me search until I've typed at least 3 characters. Let me show you what a Puppeteer test for that looks like. Okay, so here's what our test looks like. So the first thing we do is we go and grab this search button by its ID from the page, and then we interrogate the disabled property, and we want that to be true. And you'll notice I'm using async await here because Puppeteer is promise based. So everything is going to be promises. That's why we use async await. So anyway, we go and interrogate this button, make sure that it's disabled. Then we go and fill in the movie name text box with the characters A, B, C. And then we check the search button again and make sure that it is no longer disabled. Okay? And so if you're wondering where these come from, if you look inside my component here, here's the button and it has an ID of search button. And here's the input and it has an ID of movie name. Now, in general, when I'm on a project, I sort of have a rule that JavaScript owns the IDs and CSS owns the classes, the class names. And so that makes it safe for me to use IDs in my tests. But if you're working in an environment where you have designers or where people are accustomed to using IDs in their style sheets, then it might not be safe to use an ID to do your test. In which case you may want to use a data test ID. So you would add a custom property here called data test ID, and you would use a selector for the data test ID attribute. So bracket data test ID equals whatever the data test ID you gave it. Okay. And so I'm going to remove the skip here and we're going to watch this test fail. So when I save this, we can see we now have a failed test, and it's failing because our search button is not disabled. You can see it right here. It's a regular button. There's no disabled property. And so to make this work, we're going to need a little bit of React magic. And voila, we have a passing test. I'm not going to bore you with all the details of all of the code, but basically the main bit that's working here is I've got this handle input function that gets triggered when I type in the text box, and it sets a disabled search based on the length of the value typed in, and then it also sets the movie name to the value typed in, which we're going to need for later. If I introduce a delay here when I fill out this form, you can actually see it working in a real browser. Here, I'll show you. We add a delay, run our test, and Puppeteer does its magic. So this is that dance that we all do, right? Where we write a bit of code, try it in the browser, see what's broken, go back, change a bit of code, try it in the browser again, except that now it's all completely automated for us. So we just wrote a few lines of code and we have this working for us automatically. So that's going to save us time over the lifetime of our application. It's also going to give us a repeatable way to test the application from the perspective of the user. So it's very, very valuable. And that's part of the reason why I absolutely love doing it this way. Okay, so let's move on to the next one. We'll get rid of the delay for now so that it doesn't slow down our tests. And then we'll collapse this test so that we can see what we're doing. And we'll start on, it tells me when we're searching. So the idea here is to provide some indication to the user that a search is happening prior to the results returning. And this is something that can be very, very tricky, right? Because you've got to write a test that is going to interrogate your UI after the request has been made, but before the response has been received. And when you're dealing with network requests, it's often difficult to predict exactly when the response is going to come back. So there are a lot of hacky solutions to kind of testing this kind of thing where we rely on delays, but that creates very flaky tests. The good thing is Puppeteer has a great way of testing exactly this kind of thing. So let me show you. Okay, so here's our test. Let's walk through it. So we'll get rid of this skip. As you can see, Puppeteer allows us to intercept requests. So by turning this on, set request interception on our page, what we're saying is that we want to intercede in potentially every network request that the page makes. And then we can register an event handler for the request event. So whenever our page makes a network request, Puppeteer will run this callback function that's here. So the nice thing now is we know exactly when a request has been initiated, and before responding to the request, which is what we're going to do here, we can assert that we've got a label with an ID of message and that it is displaying text searching. So that means as soon as the network request happens, we're going to show the user some text that says searching inside of an element with an ID of message. And then after we've done that, what we can do is we can send a response using the respond method of the request that gets passed into this callback, and we can control exactly what that response is going to be. So here we're sending back a dummy posters array. And this dummy posters array is coming from the fixture that we created based on a real response from the actual API. So we're not calling the API, we're sending a dummy response, but it's structured exactly as if it was the real response because we created it based on that. And importantly, we have this done function here that tells us that the test is over. So because this code is running asynchronously inside of a callback, we want to make sure that the test doesn't exit until we've actually done the work of testing what we're trying to test. So this is a registered callback. So now we need to manipulate the page so that we fill in some text into the movie name field, and then we click the search button. And another precaution that we've taken here is we've put this expect assertions at the top. And what this is going to do is it's going to ensure that there are 3 assertions in this test. So we don't want to have this assertion get missed because it's in a callback, and so it's happening asynchronously. So we want to make absolutely sure that all 3 assertions have run within the scope of this test. So now if we save this, it should fail. And there we go, we've got a failing test. And you'll notice the reason that it's failing right now is that we're expecting 3 assertions and we're only getting 2 assertions. So what's happening is this assertion here is never being called because our component never makes a request to this URL, right? So because the request to this URL never happens, we never enter this code and everything just times out. So let's fix that part first. And now we've got a passing test again. So what's happening in this code is we're simply setting a message to searching when the user clicks the button. And this message is appearing down here in a paragraph tag that has an ID of MSG, which is what our test is looking for. We go out, we get the element with an ID of message, and we expect it to have text matching searching. So now that we've got that working, let's collapse it and head down and implement it displays all results. So this is what we call the happy path. It's the experience that most users of our app will have most of the time. So it's important to get to implementing that as soon as possible because this is where we're going to discover some of the gotchas, and it's also the main thing that our app is meant to do. So it makes sense to get it out of the way before we handle exceptions or alternate paths. All right, so let's walk through our test. So as you can see, again, we're intercepting all of the network requests from our page. And then we've registered a handler for the request event. So when our page makes a network request, we inspect the URL, and if it's a request to our API, we send a response containing our test fixture, dummy posters. So this is just a JSON file with an array of poster objects similar to what the real API would return to us, but one that we've made and we can control. Then we handle the response by registering an onResponse handler. And here we receive our response. We inspect its URL to see that it's a response coming from our API. We capture our dummy posters into a variable that we can then loop through and check on the page if we have an image for each element in our dummy posters. So it's helpful to go look at dummy posters at this point and see what it looks like so you can understand this code a little better. So here's the JSON file that we're using for dummy posters. And as you can see, there is a poster property in each of these movie objects that's a pointer to an image for the movie poster. So back in our test, we're looping through the results and we're checking that our page contains an element that's an image and the source of the image is the poster property for that movie object. Once we've done asserting all of that, we turn off request interception and we're done our test. And of course, now that we've registered the handlers, we have to make sure that we fill out the form and press the button. So when we save this, we'll have a failing test. And you can see our test fails because it's not finding any images with our posters. And in fact, it just exits on the first one. So it can't even find the first poster because we haven't implemented it yet. So let's head over into our component and implement this functionality so we can make the test pass. Okay, so now we have a passing test. So you can see we've captured the JSON from our fetch request extracted the results, and stored them into a posters variable. Then on our component, we loop through the posters, we map over them. We get a bunch of movie objects, as I showed you from the JSON file, and then we just insert an image with the source equal to the poster property of the movie object. So for each movie object in our search results, we're going to display an image with the source of movie poster. So now that we have a passing test for the main path through our application, where a user has entered a movie title and has received a set of results in the form of movie posters, it's important to make sure that this code will actually work against the real API. Whenever we're working with fake data or dummy data, there's always a risk that even though we have a passing test, something about the fake scenario we've created is going to be different than the real API. And so it's important to have a way to test against the real API, especially before we push any code to production. So I'm going to show you how to do that in a moment. Luckily, with Puppeteer, it's pretty easy. We've also done a number of things to sort of make sure that we're as close as possible to the real thing. So we're actually intercepting requests at the browser level rather than trying to mock out some kind of library like Fetch or Axios. And that's helpful because it's going to behave in a manner that's much more consistent with how things would behave in real life. We're also basing our test fixture on a real response that we got from the API, so that should be as close to real as possible. Nevertheless, it's important to test against the real API to make sure that our code still works. So if we look at our package.json file, you'll see we have a build script here that's going to generate a production build of our app. I've added a post build task that will run automatically after each build. And what it does is it sets an environment variable, node_env, to the value build, and then runs our UI tests. This means we can use this environment variable inside of our tests to switch to the real API instead of using our dummy data. So now in our tests, we can read the node_env variable, and then depending on whether or not this is set to build, we'll navigate to either the prod built version of our app or the dev version of our app. And then in our display all results test, we read the environment variable, and if it's set to build, we just continue with the request. So we let the request pass through to the real API. And when we process the response, instead of looping through our dummy results, we loop through the real responses JSON. So here's our results, and here's us looping through them. And it's going to be different depending on whether or not the node_env was set to build. So now this gives us a way to run our test in production mode, where we're actually hitting the real API and seeing if it works. So let's do that. Down in our terminal, we'll just run a build. And there we go, we've got passing tests hitting the real API. And this is going to happen every time we do our continuous integration or our deployment, where we build a production build of our app. It's actually going to go touch the real API and make sure things are still working. Okay, let's get back to developing. Okay, so now we can use the same techniques we've been using to implement all of the exception paths, like handles API error, handles network error. And we're going to do that using these test fixtures up here, which again are just JSON files that were generated from the real API. Okay, so I've gone ahead and implemented all of the tests now using similar techniques to what we've just learned. And everything is passing and it's all working. So let's take a quick look at a couple. So let's say, for example, we want to look at handles API errors. So as you would expect, same pattern, we intercept the request, make sure we're calling our API, and then send across an API error response, which is just a test fixture with an error. Similarly, we have network errors. So in here, we actually go ahead and abort the request with a failed message and make sure that we tell the user that something went wrong. So like I said, I'll put a link to all of this code in the description and you can go through it yourself and take a look and examine the details. But hopefully this has been instructive. Let's think about what we've learned. So the good news is everything works. The bad news is if we look at our code for our component here, this code has gotten pretty messy. It's basically a big ball of mud, but that's okay because our approach is going to be first we need to make it work and then we're going to make it better. So getting to the point where we have a functioning app or a functioning feature that does exactly what we expect it to do is a huge win. And now we've got a test harness that gives us a safety net and allows us to go ahead and refactor our code into much cleaner, much better separated, much more elegant code. And that's what we're going to do in the next video. Hey, so after seeing that, I figure you might have a couple of questions, so I wanted to address them right now. You may be wondering, why not use a component testing framework like Enzyme or React testing library to test React components in isolation? And the truth is, the more your tests know about the UI framework that you're using or the component hierarchy that you've built, the more brittle they become. So by testing from the perspective of the browser, you free yourself from the dependence on the specifics of your UI framework or your component hierarchy. That means when the UI framework comes out with new features, you're free to use those features without potentially breaking your tests. And it also means that if you want to refactor your component hierarchy, extract some components, create some higher order components, you can do that again without affecting your tests. Having said that, there are times where your page becomes really, really complex, or the part of your app that you're working on takes many, many steps to get to. So you've got to log in, do lots of clicks, and that can be a little bit of a pain in the butt to do with something like Puppeteer. What I recommend in those scenarios is to use a product called Storybook.js. So what Storybook does is it allows you to focus a single component onto a single web page. And then you can use Puppeteer to hit the web page of Storybook that just has the component that you're interested in testing. So you get the best of both worlds. You get component isolation, and in the meantime, you get really resilient tests that don't depend on any knowledge of the UI framework that you're using or the specific component hierarchy of your app. The other thing you may be wondering about is, what about unit testing? So this may not feel like the kind of test-driven development that you're used to. Usually when we talk about test-driven development, we're really looking at what some people call unit tests. The problem with the term unit test is it's a very, very misunderstood term in my opinion, and it's something that can cause a lot of trouble. In fact, you'll find that you get the most bang for your buck out of integration type tests. So yes, unit tests are important, and absolutely we will do some unit testing in the next video as we start to look at how to refactor this app and clean up the code. But it's better to actually start from the outside in, especially when we're talking about UI. So I've found it's much better to start with integration/UI kind of tests and drive your app that way. And then once you've got a solid test harness that proves to you that your app is working in the way that a user would expect it to work, then you can go back, start to refactor, and for complex bits of code, you might drive those complex bits of code with unit tests. The other thing to note here is we are working with the front end only. So if I was building the API to go along with this front end, then you would see what might look like a lot more traditional sort of quote unquote unit testing taking place. If you enjoyed this video, I highly recommend you check out devmastery.com and sign up for my newsletter. I send information about upcoming videos, as well as links to articles and other interesting insights about how to improve your code and advance your career. Mastery Monday is here on YouTube every Monday, so please subscribe and hit the notification bell so you never miss a video. Thanks so much. Catch you next time.